Hi, we're in the North Woods of Central Park. We're in the lock, just north of the ball fields at the north end and just south of the swimming pool and skating rink. We're going to do a relative humidity experiment with two thermometers. We use what's called a wet bulb thermometer, which has paper towel wrapped around the bottom, and that paper towel is wet. And then we use a regular ambient air thermometer that just gets the air temperature. So we spin each of them for about a minute, and by getting the difference in the two thermometers' temperatures, we can figure out the relative humidity. Now, why would they be different? Well, because when you spin the wet bulb, you evaporate water from that paper towel. The evaporation of water takes heat away from the bulb and lowers the temperature. So we can get the difference between those two thermometers, and the fact that water can evaporate into the air from the wet bulb, well, if the temperature drops a lot, then you've got low humidity, plenty of room in the air for more water vapor to evaporate. But if no water evaporates, like it might today, you've already got air that's got a lot of water vapor in it, no room for more. Plus, we're relatively chilly here, so we don't have a lot of energy in the air to evaporate water from that wet bulb. So this is a way of determining relative humidity. We do it along with our earth science reference tables. So we're going to start with our dry bulb, which, right here, dry bulb thermometer. Maybe I can get, and it's got a reading of, in centigrade, we're going to use centigrade. It's got a reading of, looks like 8 degrees centigrade. 8 degrees. So we're going to spin it for a minute. Spin it for a minute. All right, here we go. Watch the spinning. Look at my hand. I'm very good at this, right? Natural ability to spin thermometers. We're looking at the beautiful park. There's a squirrel. I've had a flicker. I've had some white-throated sparrows, some cardinals. Mallard just swam by, but relatively quiet for spring migration. Yesterday I had some golden crowned kinglets. Day before I had a Louisiana water thrush, swamp sparrow, fox sparrow, but don't see much today. I'm still spinning. I'm spinning my dry bulb, see what the temperature is. We do the same operation to both thermometers. Spin the wet, spin the dry. Very exciting. We're at a minute 17. It's just about a minute that we've spun now. Give it another 10 seconds. 5, 6, 7, 8, 9, and 10. And let's see what we got. So we stop spinning. There's our thermometer leaning against my little arm. And we maintained 8 degrees centigrade. So 8 degrees centigrade. Now, we're just going to go right on putting this thermometer back on. Well, got to get rid of the other one. This one over here, and grabbing wet bulb. Here's wet bulb. You see, wet bulb has this piece of paper towel that is wet. I wet it with the water. Oop, didn't mean to stop that. I wet it with the water here. And let's see what it's reading. Wet bulb, what are you reading? Just out of curiosity, you're at 7, which could mean that we already have our answer, that it's about a 1 degree difference. So we're going to spin now for about a minute. Spin for a minute. A 1 degree difference would be about right. 1 degree difference would be about right. Probably give us a humidity in the zone of 80%, which is, I don't know. I'm going to check it after this. Probably correct. We'll look out this way now. This is the stream headed towards the Harlem Mere, headed to the north. So that's a flicker flying in the background. There's a female cardinal. I don't know if you can see that land. It's on that little branch up there, but all right, let's come back to me. We're at a minute 14. This shot's been running. See, I'm still spinning. There we go. Spin, spin, spin. It's been about a minute. Let's give it another 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, and then put this here. We spun down to, 7. So it's just 1 degree difference, 1 degree between the wet bulb and the dry bulb on this March. By the way, it's March 29th, 2020. We're in the Corona lockdown. I got my masks for when I leave. I'm wearing a bandana today and filter mask. Not a very good filter, but I'm not really around any people right now. So I'm gonna stop, and I'm trying to think if there's anything else I want to tell you, but I don't think so. We've gotten our 2 readings, our wet bulb, 7 degrees, and our dry bulb, 8 degrees, 1 degree difference. And actually, I'm going to turn off, write that down, and check the actual figure for this moment in time, and then I'll get back for one last word. Well, you know, I was thinking like 2 weeks ago I should get a selfie stick. I think I still should. So I checked. The humidity right now, according to the National Weather Service Central Park reading, is 92%. So we'll see how we do based on what I've done. Here I am writing that down. You can't see it very well, but 92% is the actual. And you know, shaky wakey woo. We're gonna go back and see how we did. I could actually go online right here and see from a reference table, but I'll go back to the old homestead. Blue jay, blue jay, blue jay, blue jay. You know, I just wanted to give you a little bit more of a view of this wet bulb thermometer, just so you get the idea. I don't think it's very clear from what I've said so far. So you can see I just took a regular metal thermometer that we've used these at school, and I wrapped paper towel around it. Right? Sorry it's not in focus. It's really annoying. It thinks it's smarter than me. I wrapped paper towel around it, and then I just dipped it right here in the water bottle. The water was a little warmer, so, but by the time we've done this, I've done this twice because I blew it the first time. By the time we did it, it was perfectly acceptable. And then again, the dry bulb, just to clarify over here, just so you see the difference. The dry bulb, and it's just a regular air thermometer. I mean, it's just reading the air temperature. It's not, doesn't have anything on the bottom of it. Okay, so that's the dry bulb, and then here, the wet bulb, and we get the difference between the two of them, and that difference can then be used to determine the humidity. And again, if you go to the reference table, page 12, you'll be able to see a chart that helps explain that. But we're going to go back now and we'll look at the chart together. I'll add that to the video, and we'll have the rest of our Sunday to ponder the reality of relative humidity. It's still a blue jay screaming. Sometimes that means there's a hawk around, you know. Sometimes they're like yelling because they want the hawk to go away. So for all I know, there's one like right over my head. There is somebody over my head. I'm looking with my binoculars. Oh, it's the blue jay yelling. It's right over my head. So anyway, I don't know if you can. He's up there, dancing around. You can't see him. We're at the Amiable Child Monument, which is about 120th and Riverside. Monument to remember a poor little guy who fell down the cliff here in 17, 97. And I just wanted to mention one last thing. These thermometers together are usually slung, not usually separated, but that's okay. It doesn't really matter since we did it so close in time. And together they're called a sling psychrometer. So I just wanted to make sure that I mentioned that in this edition of the video. And here we are again at the monument to the amiable child who fell down these cliffs in 1797. We're back. We're going to determine the relative humidity. How are we going to do it? We're going to use the Earth Science reference tables. Earth Science reference table, page 12. I think this is like the 8th time I've done this. I hope I get it right this time. So, how do you get the relative humidity with this table? First thing, get the data that you got outside. Dry bulb is your ambient air. Our dry bulb temperature was 8. Then, wet bulb. Our wet bulb temperature was 7. So you immediately have something to do, and that is you take the difference between the wet bulb and the dry bulb temperatures. The difference for us is 1 degree. Now you'll notice the top row here starts at 0 and goes to 15. Each one of those numbers from 0 to 15 is a difference that you have measured potentially between the wet bulb and dry bulb temperature. Now today out in the park I measured a 1 degree difference. 8 for our air temperature and 7 for our wet bulb. That 1 degree difference then is applied to the table by simply going down the one column until you reach what's called the dry bulb temperature in the first column to the far left. So I'm in the 1 column, 1, the difference between wet bulb and dry bulb, and then I go over to the dry bulb column. Those are not the same thing. And I go to the temperature that I determined outside in the park, which was 8. Then I go over to the 1 column, and voila, that means there in French, we determine a relative humidity of 87%. Now, when I checked the National Weather Service, the relative humidity was 91 at one site, 92 at another. Why are we off by 4 or 5%? That's because our thermometers could only measure to the nearest whole degree. If we could have measured to, say, 3/4 of a degree difference, I think we would be closer, or even 7/8 of a degree difference, we would be closer to the 91 or 92%. But as it is, we have a technique for determining relative humidity. You go to whatever location you're working at with a wet bulb and a dry bulb thermometer, otherwise known as a sling psychrometer, and you spin them, I would say for a minimum of a minute, and you determine the temperature on each, note them down, take the difference, and look at your Earth Science reference table. Go to the difference column, drop down to the dry bulb temperature, ambient air temperature that you determined, and you will then have your relative humidity. This has been a very exciting morning, and I hope that you've learned something about how to determine the relative humidity.